Hello, welcome in this video lecture. After completion of quantum numbers and Bohr's theory, we are moving towards two important concepts. In this lecture, we have to study two important concepts. One is the Paulies Exclusion Principle, and second one is the Hunds rule of maximum multiplicity. Now first we see what is Paulies Exclusion Principle. As in the Bohr's theory, he put forth the postulate that is, by taking hydrogen atom as a principal atom which is containing only one electron. But this is the limitation of Bohr's theory. To eliminate this limitation, next 3 to 4 theories coming. Out of these two we are going to study in this lecture. So Pauli's exclusion principle is put forth for the atoms having more than one electron, and this is particularly proposed by the scientist W. Paulies or Wolfgang Paulies in 1925. According to Pauli's exclusion principle, whenever any element containing more than one electron, that is 2 and more, then according to its postulate, no two electrons in the same atom having the same set of all four quantum numbers. Right? Very simple and easy statement given by Pauli as an exclusion principle. That is, whenever any element containing more than one electron, that means 2, 3, 4, 5 electrons, then according to his postulate, no two electrons in the same atom can have same set of all four quantum numbers. That is, we have already studied there are four quantum numbers, and in the atom it is never observed that it is containing two electrons having no all four quantum numbers in the same manner. And hence, if we are taking a good example, see the example, what it means: every electrons an atom is described by four quantum numbers. A single atom or single electron is explained by four quantum numbers. Which are these four? First one is the principal quantum number denoted by n, and its energy levels may be 1, 2, 3. This is the first explanation of electron given by principal quantum number n, that is energy level or cell 1, 2, 3, etc. Second quantum number is the azimuthal quantum number denoted by L. It explains the shape of orbital. And shape of orbital, that is, there are four types of shape according to their orbitals, that is S, P, D and F. Numerically it is explained by 0, 1, 2, 3. See, in azimuthal quantum number there is a 0. In principal quantum number, energy level is never be 0. It is 1, 2, 3. And azimuthal quantum number is S, P, D and F, it means numerically it is explained starting with 0, 1, 2, 3. So this way, this is the second particularly. Then third principal quantum number is magnetic quantum number. It is denoted by Mi, magnetic quantum number Mi. Orientation, it explains orientation of orbital. Magnetic quantum number always explain the orientation of orbital, and it is minus I to plus I, or it is having orientation. For example, p orbital is oriented in the manner of px, py and pz. This is magnetic quantum number always shows orientation of orbital. And fourth one, spin quantum number, that is ms. S stands for spin quantum number, and it explains the spin of electron if it is in clockwise direction plus 1/2, if it is anti-clockwise direction minus 1/2. So with the help of quantum numbers, single electron is explained by using these four quantum number, right? Isn't it? Are you understand? Okay. Now each orbital can hold a maximum of 2 electrons. S orbital is having 2 electron capacity. P orbital is having 6 electron capacity. D orbital is having 10 electron capacity, and F orbital is having 14 electron capacity. Means minimum a orbital contains 2 electrons, and these 2 electrons can be explained with the help of Paulies exclusion principle in this manner. What is the Paulies exclusion principle? That is, no 2 electrons present in the same atom having all 4 quantum numbers same. Okay, how it is explained? See the example. Focus on this example. That is helium. Helium is having atomic number 2. Remember, helium is having atomic number 2. Hence, its electronic configuration is 1s2. What is the electronic configuration of helium atom? 1s2. Both electrons are present in the same 1s orbital. 1s orbital. Their first 3 quantum numbers are N, L, M. N stands for principal quantum number. L stands for azimuthal quantum number. S stands for Mi stands for magnetic quantum number, are same. See carefully. 2 electrons, 4 quantum numbers. Principal quantum number of both electron is, principal quantum number explains energy level, first energy level, N. Azimuthal quantum number explains the shape of orbital, starting from S, P, D, F. S मध्ये आहेत. That's why it is having same azimuthal quantum number L. Third quantum number is the magnetic quantum number I. It shows particularly orientation or shape of orbital. It is present in S orbital in the same orientation, but fourth quantum number, see well, 3 quantum number same, but fourth quantum number is the spin quantum number ms. It is different. One electron is having upward direction and another electron is having downward direction. One electron is having plus 1/2 spin, moving in a clockwise direction. Another electron is having minus 1/2 spin, moving in anti-clockwise direction. Hence, fourth spin quantum number is different for these two electrons present in the helium. Understood? Hence, Paulies exclusion principle is satisfied. So, for Paulies exclusion principle, always remember the example of helium having two electrons, but all four quantum numbers are not same. First three are same, fourth one is the different. So this is one of the example which satisfies Paulies exclusion principle. Okay. Now we have to moving. This is about the Paulies exclusion principle. Remember and focus on this statement. Very simple statement. No two electrons in the same atom. We have taken helium as a element. For example, no two electrons present in the atom can have the same set of all four quantum numbers. This is a very easy and important example which explain the Paulies exclusion principle. So this is about Paulies exclusion principle, and now we are moving towards the second important principle, that is called as Hund's rule of maximum multiplicity. Hund's rule, H-U-N-D apostrophe S. Hund's rule. What is Hund's rule? See the statement. When electrons occupies orbitals of equal energy, one electron enters in each orbital singly before any orbital gets second electron, and all single electrons have parallel spin. All single electrons have parallel spin. Okay, parallel spin. So for this we are taking a good example, that is how the filling. Now remember, first we discuss what is the Hund's rule. Now remember, whenever the atoms like uh, electrons containing 2 to 3 or particularly 6 electrons in atoms. Now we see that Hund's rule explain first how the filling of electron takes place in different orbitals. As we know that there are four different atomic orbitals. Which one these four different atomic orbitals? Okay, that is s orbital, p orbital, d orbital and ef orbital, right? Now we are taking specific examples, that is nitrogen. Nitrogen is having atomic number 7. नायट्रोजनचा atomic number किती आहे? 7. Atomic number 7. Now whenever, according to Hund's rule, how these 7 electrons are get filled in various atomic orbitals. During the filling, remember that as it is containing 7 electrons, the electronic configuration of nitrogen atom is as shown in the slide. That is 1s2, 2s2 and 2p3. Okay, 1s2, s orbital having capacity of how many electrons? 2 electrons. p orbital is having total capacity of 6 electrons, that is px having 2 electron maximum, py is having 2 electrons and pz is having 2 electrons. Maximum capacity of p orbital is 6. As nitrogen atom is having 7 electrons, its electronic configuration is as shown. 2 electrons in a first energy level, that is 1s2, 2 electrons in 2s2, and 3 electrons in 2p orbital. Okay, in 1s2, 2s2, there are 2 electrons. Now the 2p subcells has 3 orbitals. P orbital is having 2 subcells, that is 2px, 2py, and 2pz. How many subcells for p orbital? 3. That is px, py, and pz. These are the 3. Now each of these orbitals have equal energy, px, py, and pz. S orbitals are having lower energy, p orbital is having higher, but subcells are having equal energy. According to now Hund's rule, each 2p orbital gets 1 electron first before pairing begins, right? 1s2, 2s2, up to this 4 electrons completed. But in the filling of 2p orbital, the entry of electron takes place in such manner that px orbital is filled by 1 electron, 2py orbital is filled by 1 electron, and 2pz orbital is filled by 1 electron. All these 3 electrons are having same spin quantum number, that is plus 1/2 in the upward direction. So according to Hund's rule, 2p orbital gets each 1 electron in each orbital, then next pairing will be starts. That is if it is containing further more electrons. Okay, so if it is containing further more electron, then the next electron contains in 2px orbital with unpaired. Pairing will be start whenever the all 3 orbitals are having at least 1 electron, that is px1 electron, py1 electron, pz1. If it is containing next electron another, it is always added in the px and pairing will be done. So according to Hund's rule of maximum multiplicity, in case of nitrogen, all 3 subcells of px, py, and pz are having unpaired electrons with parallel spin. Understood? This is the Hund's rule of maximum multiplicity. Now we are taking another example how the diagram looks. See, like this diagram in this way. In case of nitrogen, 1s orbital having 2 electrons, one is having upward spin, another one is having downward. Pairing is there. In 2s orbital, one is having upward spin, one is having downward direction spin, paired electron. In case of 2p, px, py, and pz containing at least one unpaired electron, and all these 3 electrons are having parallel spin. So nitrogen is having such type of diagram, orbital diagram, according to Hund's rule of maximum multiplicity. So this is particularly Hund's rule of maximum multiplicity, which gives the filling of electrons is observed. How it is occurs in this way. Suppose we are taking another example. Okay. So again I will repeat the statement of Hund's rule of maximum multiplicity. So we have just see the example of nitrogen. It is having hybridization, electronic configuration 1s2, 2s2, 2p3. And in Px, Py and Pz, 3 electrons are unpaired with parallel spin. So according to Hund's rule of maximum multiplicity, this rule explains the filling of electrons in various orbitals and suborbitals. According to this rule, when electrons occupy orbitals in an equal energy level, this is very important, Px, Py and Pz is the equal energy level, one electron enters in each single orbital. Whenever all equal energy level orbitals are having same number of electrons, that is 1, then second electron is always entered in lower energy suborbitals and pairing is start. All single electrons are always having parallel spin. So this is simple way to explain Hund's rule of maximum multiplicity. Okay. So in this short video lecture we have studied Paulies exclusion principle and Hund's rule of maximum multiplicity. You can take different examples. Nitrogen is having 7 electrons. Electronic configuration is 1s2, 2s2, 2p3. Oxygen is having atomic number 8 and electronic configuration is 1s2, 2s2, 2p4. In 2p4 orbitals, suborbitals are having electronic configuration. Remember that 2px2 pairing of electron takes place. Py contains only one electron and Pz contains only one electron. This is according to Hund's rule. So you can take such type of examples for practice. Okay, thank you.